Welcome to the overview for Chapter 7. This chapter contains a handful of integration techniques. We start with integration by parts, then some trig and trig substitutions, and then partial fractions. All these techniques essentially transform your integral into one of the basic formulas. In section 7.5 and 7.6, we will see some strategies for integration. In section 7.7, we revisit some ways to approximate integrals, some old and some new methods. Finally, we end with improper integrals and challenge our perceptions of infinity. Our first new technique is integration by parts. From derivatives, we remember the product rule. Integrating both sides of the equation, we get a relationship between products. A simple rearranging of terms, we get the formula for integration by parts. The next section takes on trigonometry. We already have a handful of formulas based on derivatives of certain trigonometric functions. But in order to solve for other combinations of trig functions, we refer to the trig formulas to rewrite integrals into one of the forms given in our list. After getting some background with trigonometric integrals, we turn to integrals with radical signs. More specifically, we recall that the derivative of inverse trigonometric functions involve very similar looking expressions. With some help from special substitutions, we can turn these integrals with radicals into integrals with trigonometry. After integrating, we just have to remember to change back to the original variable. Our last technique is actually an algebra problem. We used to combine several fractions into one fraction, but with integrals, a big fraction would most likely be difficult to integrate, and so we would be interested in separating them into smaller fractions so that we can integrate easier. We have general rules of thumb to follow. We bring back long division, and the rest of the ideas is simply algebra. In this section, we pull out our short table to see how we can transform integrals into one of the basic integrals. We try to wrap up our techniques with some sort of algorithms so that we can attack the integrals. Simplification and U substitution should always be on top of the list. If these techniques don't work, we try to classify the integral into one of the techniques. This section digs deeper into a larger table of integrals. Most of these integrals can be derived from one of the techniques given. This large table can be used to skip over some details of particular techniques and to get a specialized formula for your integral. Another quick way to compute integrals is by using computer algebraic systems. But be careful, sometimes the systems will take a different and more algorithmic route and would give a more expanded answer. We go back to estimating integrals using old techniques. We remember the left and right endpoint rules. We look at the midpoint rule and compare it with some new techniques. The trapezoidal rule uses trapezoids instead of rectangles to make estimates. Then there's Simpson's rule that uses the area under parabolas. The section analyzes these approximations by looking at errors they produce. Finally, we look into improper integrals. The idea of an infinite or unbounded integral may seem paradoxical, but mathematically, some of these may actually be finite. Imagine an unbounded curve that has a finite area, or an infinite area revolved around an axis that would produce a finite volume. So let's get ready to integrate.